Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily Leetcode problem, and the problem's name is number of students unable to eat lunch. So let me describe this problem in my own words. What you will be given is you will be given preferences of let's say a fixed number of students. Each student either prefer a zero type lunch or one type lunch. Okay, and basically the lunch is of sandwiches, so zero type sandwich or one type sandwich. So sandwiches are of two types, zero and one. Okay, these are the types of sandwiches available. Okay, in your cafeteria, and students either prefer zero type sandwich or one type sandwich. Now what you will be given is you will be given two strings. Okay, so one of the strings is representing a stack of sandwiches. Okay, so this is stack of sandwiches, and another string will be representing queue of students and their preferences. Okay, so this is queue of students. They are standing in this line to get the sandwiches. Okay, and sandwich can be taken only from the top. Okay, so this is a stack, so topmost sandwich should be taken first. If let's say the sandwich at the top is zero and this student is preferring zero sandwich, then okay, that is totally fine. You will give him the zeroth sandwich and this student will leave the line. Okay, but if let's say there is other way around, this student is preferring a sandwich 1 and of type 1, and the top of stack is having a sandwich of type 0. So what this student will do, he will go to the end of the line and wait for the sandwich with type 1 to come on top and his turn. Okay, so this is what he will do, and this whole procedure will continue till either all the sandwiches are distributed or there is a condition that the topmost sandwich is not wanted by any of these students. Okay. So if this kind of sandwich is not wanted by any of the students, then in that case you cannot distribute any sandwich further, so you will terminate. Okay, this is what the problem statement is also saying. Let's also read the problem statement for just once. The school cafeteria offers circular and square sandwiches at lunch break, referred by numbers 0 and 1 respectively. Okay, two types of sandwiches. All the students stand in a queue, as I told you in this particular diagram you can see. So each student either prefers square or circular sandwiches. Okay, so these are the two types. Each students prefer one of these. Okay, and the number of sandwiches in the cafeteria is equal to the number of students. Okay, so the number of sandwiches, this size of this particular string is equal to this particular string. Okay, or number of students is equal to the number of sandwiches. Okay, the sandwiches are placed in a stack, as I told you, in this way, in stack form, one on top of other. So at each step, what you can do these two things. If the student at the front of the queue prefers the sandwich on the top of the stack, it means that these two are matching. Let's say it would have been 0 instead of 1, then this student would have got this topmost sandwich and left the queue. Okay, so if the student at the front of the queue prefers the sandwich on the top of the stack, then he will take it and leave the he or she will take it or leave the queue. Okay, and if that's not the case, he or she will go in the end of the queue. Okay, so this is the second scenario. So what you have to do is, you have to do this continues until one of the queue students want to take the top of the sandwich. Okay, so this student going to till the end of the queue and waiting for his turn will continue till one of the student take the top sandwich. Or there can be other way around also, that the top sandwich is not wanted by any student, so in that case we will stop the process of distributing the sandwiches. Okay, so you will be given two arrays instead of string. It is arrays. It was a little mistake on my side. So instead of string, the students and sandwiches will be two arrays, where sandwiches, each entry in sandwich is the type of the sandwich which is present in the stack as that particular position, and each entry in the students array is the preference of the student. Okay, so for example, the 0th indexed student prefers sandwich of type 1, and at the 0th index there is sandwich of type 0. Okay, so what you have to do is, you have to return the number of students that are unable to eat. Okay, those students who did not get any type of sandwich. Okay, we have to tell how many number of students are those. Okay, so this is what we have to do. Now before thinking of an approach, let's have a look at the constraints also. According to the constraints, the length of the sandwiches is of order 100. Okay, and yeah, students length and sandwiches length will always be equal, as it was told in the problem statement also, and both sandwiches and students preferences are either of type 0 or 1. Okay, so these are the constraints. So what we can do is, as you can see, the constraints are pretty low, so even a n square solution will not do us any harm. That will also be accepted. So we can run a simulation kind of thing, just doing all the things that we are being told here. Okay, so just we can try to simulate this problem, or else we can have an optimized version also of that simulation. So let's see how we can approach this. So what we can do is, let's say we are at this particular sandwich. Okay, so in the entire queue, starting from the very first student, we can ask everybody who wants this sandwich. Okay, one by one. Okay, and we should implement this queue in a circular manner. Okay, so when you are at the last student, then you should come back to the very first student. Okay, so it should be implemented in a circular manner in order to represent this student going to the end of the queue if if his or her choice is not there on the top. Okay, so what we will do, we will implement circular queue. Okay, and try to distribute the first sandwich and ask from left to right direction. Okay, from the very first student we will start asking who wants this sandwich. Okay, if none of these students wants that sandwich, then we will terminate. Okay, or else if one of them wants that sandwich, we will give it to him and mark the student's sandwich preference as -1 to indicate that he have already got that sandwich. Okay, so this is one approach. So how we can implement this approach of giving each student try at the top of the stack starting from the very first student. So what we can do is, let me bring the code here so that I would be able to explain in a better way. Okay, So what we will be doing is, we will be having two pointers. So one of these pointers will be pointing to the top of the stack. You can call this one as pointer 1, okay, or pointer sandwich, whatever the name you may like. And we will be having another pointer which will be pointing to the front of the queue, or the current student being asked for the sandwich. Okay, so you can call this student pointer. Okay, so these two pointers will be there. For each sandwich which is on the top of the stack, we will ask every student. If one of these students is wanting that sandwich, then we will remove that student from the queue. Okay, so this is what we are essentially doing here. Firstly, initializing two pointers. Okay, first pointer is starting from the 0th index, which is the sandwich pointer. Now the second pointer is also starting from the 0th index, which is the student pointer. And yeah, we will continue this whole process till all the sandwiches are distributed. Okay, so if the top sandwich is the sandwich which is being preferred by the current student, in that case you will mark that student that he have already got the sandwich. Marking this student visited. Okay, that's why we are putting -1 here in this array. And then what you can do, in order to implement this cyclic queue, what we will be doing is, let's say there is a array of size, let's say 4. Okay, so size is 4. When you will be at the very last index, which is 3, so when you will add 1 to this last index and take modulo of size, which is by the way 4, so what this whole thing will turn out to be, it will be nothing but 4 modulo 4, which will be 0. So this is how we can implement the circular indexing or the circular queue. Okay, so by taking modulo with respect to the size of the queue. Okay, so since it was a 0 based indexing, as soon as you reach the index which is equal to the size of the queue, it will be it will make you to point to the very first index, and in this way whole thing will continue. Okay, so that's why this thing is there, circular indexing or circular queue, you can say. And then if you have distributed the current sandwich, then you will move the sandwich pointer also. It is indicating that next time your top of the stack will be this particular one. Okay, so that's why increasing sandwich pointer also. Okay, so then if that's not the case, let's say the top sandwich is not the one that is wanted by the current student being pointed by the student pointer, then in that case you will ask all the students which are there in the current queue if any of them wants the current sandwich. Okay, and you will also have a check with count. If you have checked with every student, then there is no point in continuing the whole thing. In that case you will break, and it will be understood that okay, somehow nobody wanted the sandwich on the top of the stack. So nobody wanted the sandwich on top of stack. Okay, so in that case you will break, and you will return the size of the whole array, since both of the arrays, students and sandwiches, will be having same length, minus the sandwiches which have been already distributed. So that many number of students will be still there who have not eaten or got their lunch. Okay, so this is what we will be returning. And as far as time complexity is being concerned, so theoretically we can say that if you take a loose upper bound, it can be size square. it will be lesser than that, but theoretically we can say that, or if we take a loose upper bound of this particular time complexity, so this can turns out to be the time complexity of this whole algorithm. Okay, loose upper bound. Okay, now if we want to further optimize this thing, how can we approach it? Okay, for that let me explain another approach. Let's copy the code also. So let me take another slide. So this is another approach. We will optimize this approach, that instead of asking every student, what we can do is we can simply count the number of students who want the 0 type sandwich. So let's say 0 type count. Okay, and we can count the number of students who want 1 type sandwich. Okay, 1 type count. Okay, so we can have these two variables representing the number of students wanting different types of sandwiches. Okay, so instead of once the top of the stack is being not wanted by any student, we can check whether we are left with some students who will want that particular sandwich. In case that particular sandwich is not wanted by any of those students, we will terminate the whole process. So we will optimize the approach, and this whole loop thing will not be required. So we will not be required to ask every student one by one. Instead of that, we can use make use of these two variables. How we can do so? Let's see. So this is the approach. First of all, you will see how the 0 type sandwich and 1 type sandwich are needed by the students. So we can store those in two variables. So once we get hold of the number of sandwiches of 0 type needed by students and number of sandwiches of 1 type needed by students, then we will do a single traversal of the sandwiches array. If the top sandwich is of type 1, then we will see that whether there are some students left who want type 1 sandwich. If that is the case, then we will decrement. Else, if there is no student left who want type 1 sandwich, in that case you will simply return the number of sandwiches distributed subtracted from the number of sandwiches that there were initially. Okay, so that number of students have already are left who have not got their lunch. Okay, so these number of students have already got their lunch. So number of students who have got their lunch. Okay, who have got their lunch. Okay, and in order to find the number of students who haven't got their lunch, you will decrease this thing from the whole number of students, which is size, by the way. Okay, and same thing will be applied for the 0 type sandwich. Similar logic. And yeah, that's pretty much it. If all the sandwiches are distributed and this loop does not terminate anywhere, then you will be returning that okay, all the sandwiches are distributed to every student, so no one is there who is hungry right now, so you will return 0 in that case. And the whole time complexity thing of this particular one will be of order of size only. Okay, and this time and also I forgot to talk about this was time complexity. I forgot to talk about the space complexity. So in this we can easily see that we are not using any extra space, so that's why space complexity wise it will be order of 1 only. And this second optimized approach also is not using any extra space, that's why it will also be order of 1 or constant. Okay, And this is the whole approach. First, let me again describe, give you a summary. So first approach is relying on making a simulation kind of thing with the circular array and stack. Okay, so this circular array logic is working like this. You are doing modulo with size, so you are mimicking that circular queue. Okay, and you are asking every student, okay, who wants this sandwich on the top of the stack. If nobody is wanting that, then you are stopping the whole process, and you are doing simulation kind of thing here. So a loose upper bound of time complexity would be size square. In order to optimize this, what we are doing is, in the next approach is, we are instead of asking every student, we are just storing how many number of students are needing 0 type sandwich and how many number of students are needing 1 type sandwich. Okay, now with that out of our way, we will just simply go through the whole sandwiches array and apply this logic. If there are certain number of students who want the top sandwich, then it's fine. If that's not the case, then you will return the students who have already got the sandwiches subtracted from the total number of students. So those will be the number of students who haven't got their lunch or who haven't eaten. So in that case, if that's not the case, that all the students have got their lunch or have already eaten their lunch, you can say, then you will return 0. Okay, so this is the whole approach and how we will be implementing. Now if you are still having any kind of doubts or any queries in general, then you may ask them in the comment section. And thank you for watching today's problem solving session. I hope you found the walkthrough useful for honing your skills of problem solving. And please remember that consistent practice is the only way of mastering DSA. And please stay tuned for the upcoming content, and see you in the next video.